Good morning, and welcome to episode 5 of the Ridiculously Early J Morning Show. My name is Michael, I'm your host, and today we are talking about building a REPL in J. REPL is an acronym for Read, Eval, Print, Loop, something you often find in languages such as Lisp or even J itself, or Python, where you're talking into a console and you type in commands in the language reads that input, evaluates it, and then prints it in a loop. So read, eval, print, loop. Obviously, J comes with, as I said, one of its own REPLs, but we are going to implement a fancy one that has syntax highlighting. The graphical user interface that ships with J does have such a thing, but we are talking about the console, the text mode console, and that is where I am doing my work. And I wanted something that had nice ANSI color codes or VT100 color codes printing in the terminal. So without further ado, I actually made a very short start on this yesterday, and I implemented this demonstration. I was actually looking at some code that I wrote back in 2014 that implemented a REPL, and in the old days you had to, for some reason, you had to use what was called the immediate expression. So you can tell J that at a particular point, when it's done evaluating whatever code it's looking to evaluate, when it's done with that code, you can tangent labs. Sorry. You can tell J to execute a new command once you are out of the whatever is blocking it. So something that triggers as soon as you're done executing. And so that was how I was forced to create a prompt in the past. And somehow, somewhere along the line, it seems that things have changed, because this hack that I had to do, which I've been showing people for years. So if you're one of the people who have asked about how to do a read, eval, print loop, or just how to read a single line of input in J, and to continuously process those lines, you used to have to do this, where you're setting the immediate expression, and then telling it to, yes, turn it on, so that you're in immediate expression mode, and then as soon as you're done, it's going to, as soon as it would normally show the prompt, do your thing instead. So you would tell it to do next this expression, and that would be the immediate expression, which is to invoke this verb, and then go into a loop. And for the life of me, I cannot figure out why I needed to do that. Maybe it has something to do with being able to exit at the end. I'm not entirely sure. But in any case, the core of a REPL is to call this readln function. It's a foreign word that is just reading a single line of text from the standard input, and then you look for some exit condition, and then you here this is just saying echo, evaluate the input, echo it, and print it, and that works. I'm not exactly sure why I had to do it like this, though, because I thought maybe it was locking up the event loop in JQT, but I ran this in JQT. So here's a loop without the immediate expression, and it just seems to work fine. So if I just say REPL here, I can say I10, there we go, sum of I10, no problem, bye, and we're back to normal J. So I don't know what the issue was that prompted me to do that. I know that people have been asking about this for years and years, and every time it's come up, it's like they cannot do it. So I have posted to the J mailing list asking, like, am I crazy to think this used to be hard? And if so, what's changed? Or if not, what's changed? So it's a mystery to me. But in any case, That is the core idea of how you make an event loop in any language. You read, you evaluate it in some way, and then you print it or echo it inside of a loop. Nothing special to it. I guess the magic is all in the evaluation and also read. Read here is reading a single line of text. In a more sophisticated REPL, like in Lisp, you actually read, parentheses, nested parentheses. Hey, raise time. Morning. In J, the rule is that every J sentence, or at least the rule has always been that every J sentence fits on a single line of text up until we introduced these things. In the past, we used to say, I showed this before, you would say REPL is equal to, verb define. Well, verb define is actually this. It's this phrase right here. And verb is the number 3. And so the actual sentence you're executing is this. And when this conjunction, so this says, this is a conjunction that takes 2 arguments, and when the right, usually it's either a string. It's called explicit definition, and when the when you pass it a string like y plus 1, then it knows to create a verb using this definition. But when you pass it the number 0, what it does is it tells the J interpreter that it should continue to, it should read in data from standard in, read in lines from standard in until it encounters this line with a single end parenthesis. And this is true if you make it a noun. So noun is the word, is the number 0. You can make an adverb. You can make, any part of speech in J can use this pattern of define here, right? So noun define should turn blue there. Yeah. Indicating it's a string. So this entire thing is parsed as a string. And that is how you used to do things. So the implication of that is that this is not actually executed until, except it's being read in as a string. So the only line that's actually executed is this line right here. And so you can even say like, reverse this. And if you run this whole thing, then in the terminal, you will see that the input has been, because it's an assignment, you don't get output. But if you remove the assignment part, then you can see that it's reversing each of the lines in there. So this is pasted to the terminal because I'm pressing Control Enter, and it copies from here to this terminal, and then it shows you the result of the line you just executed. But bottom line, the rule has always been that J code exists on a single line all by itself, never more than one line. But now, with the advent of J902, we have this concept of multi-line definitions. And so it's a little bit more complicated than that. Because this entire thing is read, it's still read a line at a time, but I guess this now starts the multi-line definition if it's not closed. And then at the end, you can make a verb that, or let's do it like this. Add is, let's make a line that says, y plus 1. And I believe you can then end it here and say 5. So I believe if I press Control Enter here, it should say 6. Oh, but apparently not. Okay, so it is actually, the JQT is not quite caught up with this yet. Okay, but in any case, it said 6. It did evaluate this whole thing as a single expression. So it knows, you can't do that with the parentheses here. In the old days, you would say verb define, and then this, and then you cannot put the 5 here. This will not evaluate the way you want it to. See, it says syntax error. So what you actually do is you put the 5 here. And so it's evaluating this line, but first it reads that input in, and it does say 6 here. Sorry if this font is too small. Anyway, that's enough of that. We're talking about REPLs today, and so maybe there's some reason why you do have to use the immediate expression in some odd case, but for the most part, it seems like just doing the loop, this inner loop here, is everything that I needed to do. That is what we would do if we were using J's input to, if I run this right now, jREPL, I do get the input and I'm in this loop. It's kind of hard to tell. I guess one way I could tell is that if I say a equals 5, if I'm in the jREPL, then nothing happens. Oh, I am in the jREPL. Well, then okay, so maybe that is why you have to make it happen. Maybe this is why you need do next. Okay. Maybe I've answered my own question. Do next, and so now do next is equal to, if I pass that in, maybe this isn't a mystery. Okay. I don't need that. There we go. So now the cursor is not indented, and so I am not in the J console. And you're seeing I have not. My REPL is not smart enough to know that if the leftmost thing is an assignment, then you do not want to echo it, and so it is echoing the number 5 here. But if I type exit, as this loop says, then I should now be back in the J console, where if I say a equals 5, it suppresses the output. Okay, so that answers the question. That is why you need this extra thing in addition to the loop. You need to call do next, because otherwise, I guess does it just ignore the fact that I've told it to run this function? Echo in here. Let's see. Either it ignores this fact, or it refuses to provide input, or it treats this last line as input, and then this exits because by throwing an error or something when trying to read from standard input. Let's see. In here, okay, so it is executing that. I'm sorry, hang on. The idea was that we would not do this. We would just say do next. Not do next. We'd just say fake REPL. In here, so it says in here and it immediately exits. But I bet if I say a, instead of echoing the evaluation, I'm going to just reverse the echo reverse of source. So rather than evaluating it, I'm going to echo the reverse of source. So it's just, this is just like a reverse function. So hello, okay, but I bet if I put the word hello down here, that it's reading this. Yeah, okay. So that was the trick. The trick is that that when you do this loop here, it's reading from standard input, but J is already reading from, not from standard input, but from what it's treating as standard input, the input from the file. And so it would, this actually gives you a way to, you start your REPL up here, and now you use your language here. So you write code in your language, and then it executes it inside that interpreter. So I bet if I put exit there, now I'm in J, echo in J. In J, and yeah, I'm in J now. All right. Okay, so that solves the mystery that I brought up yesterday. That is why you need this immediate expression concept. Okay. And I guess in that REPL, then the idea was that this fires once, so. Oh yeah, if you didn't want to have a while loop, you could also just have this called do next main again. But since I'm in a while loop, it doesn't matter. Okay, so that solves the mystery. So that is how you make a REPL in J normally for your own particular brand of language, and you get past this issue of of reading, but I am not going to be reading from standard input. Well, I am reading from standard input, but not the way J is here. I am going to be reading keyboard input, and when I tell it to, for example, run this app, it puts the terminal into raw mode, and J seems to respect that and allow me to use my input from the keyboard here, even though it's the last thing in the file, and presumably it wants. I wonder if I put hello. Well, no, it's not. It's not using this as input to the. To the application. So I think on this line, we have explicitly put, just because of the way my thing calls, it sets the terminal to raw mode and does it. So I think none of this is actually executed yet by the time this happens. So it's not reading it. And I bet if let's see if I stop now, does it say hello? So echo hello or not? Or either one of two things is going to happen. Either I almost suspect it's not going to echo hello after I do this. I think that the act of putting it into raw mode has kind of reset Jay's idea of input, and this is not going to run. So let's find out. Hello, I press enter, I'm done. Oh, it did, okay. Well, that's interesting. Learn something new. Okay, so regardless, this is my fake REPL, but what I want is to run it inside this application framework. So what we just went through the past couple days was getting rid of all the while loops, because an event loop for an application does not have while loops. Everything is asynchronous. So we cannot do this. So this is garbage, and we will get rid of this as well, and we'll get rid of this. And we are back here. This is the simple version of the REPL. And I'm actually going to check this code in because I deleted all those spinners that I was using the other day. So GD of REPL. I think this is a nice simple REPL that has, so REPL. Well, it's not a REPL yet, but remove spinners. Since they have served their purpose and shown that we can run the input commands and the macros and animations and whatnot while the event loop is running. Okay, now what we want now is to put this thing on the screen and evaluate it. So I already have this program MJE. That's not an official name. That is the minimal J editor. It is something I started with, and I probably will change that name. Let's back up. So when I run this command, it is actually reading a file called. It is reading the source code. It is reading the screenplay that I am writing for my next scripted video. And so when I go here, I changed this a little bit this morning. I put all the imports at the top, and I moved this org file from another repository, from my JTalks repository where I keep the screenplays, to this directory because it's really part of this tool. And so org. So first of all, org is a tool that comes with Emacs, and if I read, if I open this file right here. So can I find this file? Nope. I know there's a way to make Emacs open this file, but I'll just copy it. I don't remember what it is off the top of my head, so I'll paste. Read from disk, yes. And so you get this kind of hierarchical structure. I'm also using this for my my planning here, and it's just a plain ASCII text file. If I open it all the way, it's if I say text mode, I believe. Well, this indentation is being provided by Emacs. It doesn't quite like to be. It doesn't clean up nicely when you switch out of org mode. But Emacs is a modal editor, but not quite in modal in the UI sense, where it like Vim, where it changes from insert mode to the same key doing different things. It does change what the keys do, but arrow keys always do what arrow keys do, and the editing keys generally do what editing keys do. But some keys like Control C is a prefix that's reserved for the individual mode, and so like you can assign certain functions to the control keys, the Control C prefix, Control X, that kind of stuff. But it does have modes in the sense that the same text on the screen can be syntax highlighted different ways, just like most modern text editors, and so they're always called something mode, something dash mode. So org mode, there's Python mode, there's J mode, and whatnot. And in org mode, you have it's meant for keeping to-do applications. You can say this org agenda, and it'll gather up all these to-do lines and like list of all the to-do entries. I guess it actually looks at a bunch of different files, and I don't really have it set up right, so I don't really use it for that kind of thing that much. I probably should. I kind of fallen out of practice. But you can also make like little, spreadsheets, and it'll tabulate. Make tables for you. So, if you add a column here, 5, and press tab, it formats your table nicely. You could even put like expressions in there and actually treat it like a spreadsheet. It's not just a table. So it's a really advanced tool for making kind of like hypertext, and it includes the ability to put code in. And so what I had done in the past was I would put like my J code in these little code blocks, and I would get them syntax. Supposed to be syntax highlighted. Maybe I don't have J mode loaded in this editor. So let's see, x equals 4. Yeah. That is slightly different colored, so I guess it just doesn't do the kind of highlighting I'm used to. It's been a while since I looked at this. And so the idea was that these would be slides. And so in the past, my slides were always, a heading, and then the source code that I wanted to appear on the screen for that slide, and then underneath would be the text that I would say, and then I had a window that was up here that would, so I would arrange my screen so that the text up here would be up here, right where my face is on the camera in my other videos. I'm in the lower right here, but normally I'm in the upper left on my scripted videos, and that's because the teleprompter is right there. And I have my screen set up so that if I'm looking at that, it kind of looks like I'm looking in the right place on the screen for, to be looking at the code or something like that. But anyway, so that's where the text goes, and then the actual slide goes over here, and then there's a JTerminal down here in my scripted videos. But I did that because I started doing the slides because like knowing what I'd want to say, I would have typos everywhere, and I have to go back and edit the video to remove the typos, or I would have to just live with the fact that there are typos everywhere, or it was just a pain. Like I wanted things to move a lot quicker, and so I wanted to use slides, and that did solve the problem of making it easier to put the text up on the screen, and especially a lot of text if it's in multiple lines. So for example, I think my demo, it would be a screen like that big, right? Which when you render it, that's when I press enter here, it's showing all of that up there. Previously this was on this side, and it was a little bit bigger font and whatnot. So that was a slide for me. But now I'm like, for this particular episode, I want to show how to take this text. I did this video about sand piles, and they're like a cellular automaton, and I included this code, and then I had a code golf section, and I showed this code, and I said, well, this does the exact same thing, and so this s verb is very similar to this verb right here. And I wanted to show how do you transform one into the other. Like, in fact, I even made the claim that this is the natural way to say things in J. This is how I wrote the code to begin with, and then I went back and I did this for people to make it easier to understand. And so the upcoming video is going to be all about how to transform this text into this. So it's implementing sand piles in J, and it's like probably code golf : sand piles in J or something like that. Is going to be the name of the video. But to do this, I really want to show these transformations. I want to show, I want to show my cursor coming up here and saying, okay, well, I'm going to do this, but okay, I want to, I've got this constant being used. I want to turn this into a function, and so let's do this, and then we'll pass in. Okay, now that's a function. We got to invoke it. But also now we've got this GT thing, so let's put GT out here, and then okay, so now we can use Y, all right, and so now we can do the same thing for all of these, and then at the end, we're going to wind up with all these verbs, and so now we can say, well, let's just pass GT in here, and then we don't need so much. In fact, then we can make this whole thing a fork and so on. And so this is kind of like the what I'm saying right now is kind of the presentation that I want to make. And you see I'm moving the cursor around. And so this is not something that like it's not just a slide anymore. I need a cursor on that slide. I need an editor. I need animations in the editor. And so that's the kind of motivation for this program. Basically, I'm doing a tremendous amount of work to save myself the little bit of work of doing the editing that I just did live on camera. I want this to be scripted. I want it to be something that is part of the presentation tool itself, so I can get the typing right and then come back, and when I have the presentation looking the way I want it, and I like the way it goes on screen and whatnot, then I can come back and I can read it out loud or memorize it and speak it a little more naturally, but I can record the audio for it, and then I have a nice bundled application. It's really hard to talk and type at the same time, or even to talk and look at code at the same time, because as soon as, at least for me, as soon as I start actually reading the screen, my ability to talk shuts down. So if I'm not reading the thing exactly, then like my wires get crossed, and it's just very hard. And in fact, to the point that sometimes if I'm reading the screen, I'll stop talking, kind of like I'm stuttering right now a little bit. But if you hear me say, speaking smoothly, there's a good chance I'm not reading, and so I might be like saying, oh, this code does this, this, and this, and then talking about the wrong piece of code. I think I did that in one of the streams earlier, where I was probably the 5-hour stream, where I was talking about a piece of code, and it's like I had a similar piece of code on the screen, and I was talking about it and saying it was doing something, but it was not the right piece of code, and because I didn't read it right. I thought I was in the right place, and it's easy to skip things when you're talking, and then to do that on camera, you wind up having to be an actor and memorize your lines, basically, so that you're not, that you're that you sound natural, and B, that you can concentrate on the typing, and so it's actually harder than it looks to make a scripted, to make a programming video where you're scripting it. Where in contrast, this is easy. I program every morning anyway, and so all I have to do is turn this camera on and talk into a microphone. Although I learned to use the microphone correctly. I've learned to do some lighting so I don't wind up as a gray blob with the background behind me. So there is some technical skill involved to it, but for the most part, I'm just doing what I normally do anyway. I am getting up in the morning and I'm writing some code, and the only difference now is I'm talking and probably not getting quite as much done, but on the other hand, I'm having a little more fun and at least putting some videos on my site. But the point is, this is easy, and I'm a little torn because I almost didn't put these videos on this channel because although they are related to J, and I know that my channel is basically about J and people would like, I know there is an audience for this, right? I've got 2 people in here, so hello 2 people. But I also know that A it's way early in the morning, so not too many people can show up, and B, it's a lot to watch, right? Like I watch these videos once a day, and I watch them at 2x speed because it's slow to me. But I watch them so that I can fill in the chapter headings. But I don't expect even my friends and even people who like and already know J to watch 8 hours of this stuff. But I do expect that somebody learning J for the first time might appreciate it. So I think there's a value to these videos, but it's not the same kind of video that I set out to make. I want to make these scripted videos. I want to make videos about math where I happen to be using J as a presentation tool, as a way to illustrate the point as I go along. And occasionally make videos about programming in J specifically, but like scripted tutorials. Anyway, long story short, I wanted this tool. That's what we're doing. And so now I want this REPL to work. Okay. So the way I see this working is eventually this REPL is going to be in this window. And I think right now if I press R, I get a, no, I edit that piece of text. So if I hit E to edit, I don't have all my keys set up. So it's Control F to forward, Control B to go backwards, Control H to backspace, Enter puts it back. Right. So okay. So this is new topic. This is about how does the REPL work currently. I call this a REPL, and what is actually happening. Let's go back to this file. Here's the script, and what is happening is it is reading this file. So here you see to do recap, and here it is. That is the heading in the outline view, the outline panel. All the headings appear there. So if I press, see there's color map, and if I press Shift Tab one more time, I get the full outline, and this is what we are scrolling through on the left panel here. So this does the same parsing that org mode does, and all that is the headings are lines that start with an asterisk, and if they have 2 asterisks in a row, then you're indented once, and if you have 3, then you're indented 3 times, and so on. So the number of asterisks tells you the indentation depth. And I'm not yet doing anything with that as an outliner. It's just a flat list that happens to be indented the same way. I replaced the asterisks with spaces. Okay, so then in between the words recap and color map, the 2 headings there. And by the way, the colons don't mean anything. I thought I might use them as like labels so I could go to a previous slide or something like that. They haven't done anything with that. But in between those 2, I have all these lines. And so you'll notice there is a source block, a begin source block, this block right here. That winds up being, you can have one of those per heading. You can have as many as you want in org mode, but for my tool, you can have 1 per heading. I'm sorry. And that winds up being the slide. And so the slide is still, the new interpretation of a slide is this is the initial text that will appear in the editor as of that slide, as soon as I page that slide. So if I can press 9 and 0, so I press 0 to go forward, and 9 to go backwards, and so I hit that slide, and the text of the editor, or the text of the slide, shows up in the editor there. And then the other lines after that are the lines of the narrative, the spoken lines, the screenplay, and the lines of the REPL. Okay, so REPL input. So when this thing loads, what it does is it reads this file, and it parses out all the lines that have asterisks in front of it, and those go into the outline. And then it uses those as breaks, and then it breaks the lines into each it associates. It builds like kind of a table, and the first column in the table has the headings. Has these headings on the left, The second line in the table, or the second, is a box that contains a list of boxes, one per line for the individual lines for that heading. And I think there's also like a number in it. The third column is like a number that says how deeply indented is the heading. And then there are some hidden columns that say what is the state of the REPL at that time. And so if you there's a trick going on here. So as I'm paging back and forth, there somewhere in this code there is a single giant array that contains the input and output for every command. I think my intent is that at some point it's going to be like a two-dimensional array. So you have, associating the input and output. I don't remember if that's what I did or not. I'd have to look at the code. So for each line here, I am associating a position in that array. So I'm not executing things as I go along here. It's already been executed, and I'm just displaying what exists in this array. So the color output, the input is stored as just a plain string, and then I'm rendering it colored on the fly, and the output is stored as a string containing whatever terminal escape codes are required to make these colors appear. So the things that are on the left are not indented three spaces. Those are just stored as strings. And so I'm going to restart the program now. Let's one more time. I'm going to clear the screen this time. So when I run the program, we see a lot of these permission denied. And what's actually happening is could not run the image viewer with the command viewmat. Something viewmat. So the idea is that you can define a image viewer in J, so that if you're in the console, you can have a program pop up a window or something. In fact, at one point I don't remember how to do it right now, but at one point I had J set up to run a little program that would kind of do what I'm doing with viewmat here. And it would take, if you told it to render an image, it would render it just like this. There's a Rust program that does this, and it would pop it up in one of these tmux windows. So if you this is like a windowing system for your console called tmux, and it would pop up a window like this, and it would have the output of the viewmat in there, and then you would close the window and it would be done. So you can do stuff like that, or you can, if you're in like this is a shell. I'm in a program called PuTTY, which is making a remote terminal connection. But if you have a Unix system, you can have X windows running, and then your terminal. In fact, even in Windows, you can have an X window server, X11 server, and you can tell it to actually pipe the graphical commands to a window on your local machine and draw a window. So you can do all that stuff. Obviously, I chose to make this new verb VM that puts code in the middle here. But what is happening is when I run this command, I don't have any of those little. I don't have a handler set up for viewing images. I haven't told J how to view an image. And so it's just using an empty string, and it's trying to run empty string with the path to viewmat. So whenever viewmat makes an image, it actually it's not just drawing to memory somewhere. It actually draws a PNG file called in a temp directory, and then attempts to run it with the image viewer. And then JQT that winds up popping a window up in J and so on. So what you're seeing here is this is the result of me running of the org mode file being parsed. And every time there's a line here, there are actually some lines that say viewmat. So early on in this presentation, I'm choosing to load viewmat and invoke viewmat I22. And so when you do that, load viewmat, viewmat I22, and you get that error message. So this is actually the output, the output that I am not able to capture from running this code. But the point I'm trying to make is that this entire file, every line that has this has a colon in front of it, is being run as soon as I run this as soon as I load the file in this editor. And so I've loaded the JTalk now, and I press enter, and now I'm going to view the pre-executed code. The pre-executed inputs and outputs are being viewed here. And if I break out of here with Control C, and I say names, so these are all the things that have been defined, but also if I say conames, you see all these worlds. And so what the idea of this kind of time-traveling REPL is that every time a world contains so let's see what's in let's see what's in world 51, names underscore world 51. Sorry. So that has 2 hist L0 and hist L1. What this tells me, there is a global variable called hist in hist world. Hist world. All right, I'll have to find it. But the intent is that this is telling me the indices into the history, the REPL history, the input-output history. This is telling me where was I in that history when the world, when this world was created, and where was I in the history when it was done. So I started on line 51, I executed some code, or 159, I executed some code, and then there must have been 2 lines of output, because now I'm at the end of it, I'm on line 161. So that's an example that did not have an assignment. Some of these have assignments. So let's look at world 5. Let's say I want names, right? 6. I don't have a good index into these. Most of them are not. Okay, so here we have P0. The idea here is that in world 8, okay, also, we also have to look at the copath. So if I say P0 in world 8, so P0 is a variable I use in the screenplay. P0 is palette number 0, so it's a palette I'm constructing. So P0 in world 8. Sorry. That's the syntax. So it's P0, this is like a subscript. So P0 of world 8 is this. And P0 of world 7, I don't think it was defined yet. I think this is when I'm initially defining P0. Yeah, so it doesn't exist. But now if I look in world 9, sorry, if I look at the names in world 9, P0 is not in there, but I can still look it up. I can still say P0 of world 9. So how does that work? Well, it works because copath of world 9 is all the worlds before it. And so what we're getting is like basically a linked list of namespaces. And every time we make an assignment, we append something, or actually every time every time I execute something in the REPL, every time I execute one of those lines that contains a colon at the start, it creates a new one of these worlds, a new namespace. It assigns the start and end locations of the, it tells me which lines of the history were on the screen when I entered that world and when I left that world after I executed the command, and then so code of there's a verb called code. Code of 9 should assign. Code of 8 should assign. should have assigned P0. Is it text of 8? Okay, so code of I need to think through this before I explain it right. So I had these I made these verbs that say me like that say so this is the text of slide number 8, but I need to, so somewhere I must have a mapping of these lines to the to the world numbers, and so as I page back and forth between the as I page back and forth between the lines in the text here, something is mapping this to a world number, and that world number is telling me, okay, like here, I'm showing this line, but then here I'm showing more lines. So these are already in the history, but what's changing is that hist 0 and hist 1. So this is the work that is done in world 0. Right. Okay. I hope that made some amount of sense. The idea is that we have a kind of like a time traveling system. So we've got a version control. Like we can always undo what's happening in the REPL. That's a weird thing. Most REPLs would not do that, but we're going to do that. That is actually going to be a feature of this REPL. First of all, because it's already done, and I don't want to take the time to undo it. And two, because I think it's a nice feature to have. And I've already talked about this for 45 minutes, so let's jump in and write some code. Okay, so this world stuff is already done. I should say, okay, so let's look at worlds. I say write some code, but you know what? We can't quite do that yet. So this is not what I want. We've talked about the org file. We've talked about, and we need worlds. So the code that implements worlds is in here. This is some helpers for dealing with. So we have to actually generate the box strings, and in J. So J has this idea of the alphabet, and maybe I think alphabet 12 of the alphabet, 16 of the alphabet starts these box characters. Well, these are not actually printable characters. If you echo this in J, it knows how to convert that ASCII character 16 to a box. But if you ask the standard in, if you just so this is my function put s, which or actually put c puts a single character to the console. This is coming from JKVM, and what I'm doing is I'm bypassing J's output system, and I'm talking directly to either the Windows console on a Windows machine, or I'm talking to the C runtime on a Unix machine. And when I do that, it's going to put load tangent storm JKVM. It's going to put that character on the output. So KVM. And it doesn't show anything because that's not actually a box drawing character. This is something Jay is doing on our behalf to make it easier to draw boxes. But I have to translate those. So here I'm grabbing all these characters, the 16 plus I11, right? So I11 is these numbers, 16 is 16 plus the next 11 numbers, and when you take those out of the alphabet, you get these box drawing characters, but only in J. And so I have to map these to their Unicode equivalents, so that's what's happening there. And so otherwise, we've got some stuff for talking about the current world, the concept of the current world, the concept of moving to the next world. So we create a new world namespace with co-current. We co-insert the previous world with co-insert, so that creates that linked list path. Because when you insert a namespace into the path, then it also inserts all of that namespace's path into your path, and so this provides the chain. And then here we are. If you've run some code, then that sets hist L1. Otherwise, we set histel 0, right? And so the idea is that we have a new histel 0, history list 0. So like the state at the start of this world. Anyway, init initializes the system. So what it does is it wipes out all of the so co-name list gives all the names. I think co-names is just formats it nicely. Oh, it unboxes it, I guess. Yeah, and it formats it nicely. So I'm using a regex to match anything that's called capital WORLD, and I erase all of those. So that wipes out the REPL history, and then creates this history and a counter for which world are we in, and right. And so that's how that works. And I think if you look at we'll just say copath of world 3 or something. I haven't run this program right. So in here, in here where I've run the program and I say copath of world 3, world 5. Yeah, so it just changed it all the way to Z. I was thinking that it might actually use this world namespace, but there's also a namespace called world. Names world, which is where all this magic is defined. So world, so II underscore world is the number of the current world. It's this world. So this world, where this is a function that returns the name of the namespace. Okay. What else? Okay, so then what I showed earlier is that in my fake REPL, if you said a equals 5, it actually printed the 5, and so I have some code in my exec function. So this is the function that executes one of those lines that has the colon in it in there. So I strip off the colon and the space, and then I have the string a equals 5. I execute it, and so it says. It actually looks at the tokens with the tokenizer, with the JTokenizer, and it says, well, okay, if so first of all, we have to know, is this a mutation? So do we use either of the assignment operators or words? If so, we're going to change all of the local assignments to global assignments. And that's because we're going to evaluate it somewhere in here. We actually, we run a function called do, which is a wrapper. So do is that. But when you say do in world, it's going to change that. Load worlds. Worlds.ijs. And then init worlds. So now we've initialized everything. So when I say do in world, this world, world 0, oh, maybe I have to do the thing. Maybe is it? So what is do? Do is that, but do in world. In world. Okay, I'm a little confused about why it's not working yet. Maybe I have to. What I'm expecting here is that exactly this. It's going to. Oh, I see. It's a string. I'm sorry. So you pass it a string, and then you get back. So do, you pass in the string do, and you pass it to this. This is a an adverb, so it's type 1, which means it modifies the thing on its right. So when I say do in world, it actually constructs the string. Okay, when I box that string, I have a string containing a box containing a string, and that is the representation for what we call a gerund in J, and colon 0. And when I run that, it actually executes finally that string, and when it has that name, it executes it as a verb. So this actually executes, but it executes it in the namespace of world. So if I say x equals 5, so let's look at names in world 0. And if I say x equals 5 as a string, so I put a string around this, x equals 5 in that world, I get let's try this. Yeah. So what the problem is that when you execute with some certain special names, like x and y and whatnot, then that even though the word do, sorry, oops, tmux attach, even though the word do evaluates to this primitive, it's executing this in the context of that primitive. And so the special names that we assign to like the left and right arguments are when we do assignments, they're treated specially, and so I have to do some magic to handle these special words u, v, m, n, x, y, or else they disappear. So I need to like kind of modify those names, and so it looks like I'm fixing them by changing the word y. Instead of saying x equals 5, which we just saw does nothing, it doesn't. It did not put a name in there. Whereas when I put hello and I say names world, I get hello in there. So what I have to do is I have to change this to x underscore world is equal to 5, and then that solves the problem. Now I have world 0. I have to know the name of world 0, and now if I look at name 0. Names also explicitly, so names, NL, explicitly removes the names X and Y. Okay, so in addition to all that, look, there's things being done. J is conspiring to hide this stuff from us. But the point is that in addition to what I just showed you, we also have to do special handling for these names. But we do not want to do that. We do not want to do this rewrite if we are doing it inside of curly braces, because that would create like a closure, which is not what we want to accomplish. It would be something that only executed in world 0, whereas we don't want to assign values in world 0. So those two things we need to make. We need to change all the dot equal dot to equal colon, so that they affect the namespace rather than the do function or the execution function, or even this function. I'm not sure where the namespace would go to, or where the assignment would go to, but these make it go to the world, and then we also change the variable names if they are one of these variable names. We change it by appending the name of the world. I'm already out of time, so I've explained now what the world concept is, how we're going to do the evaluation, and so really the REPL here is done. What I need to do next is attach the REPL so that when you press enter, it appends to the history, and it calls this exec function, and it builds that history up, and then shows the just append something to the this history that's being displayed. So then, as soon as you execute something, it will modify this history and do exactly what it's doing when it's parsing this. So that's a lot of talk, a lot of explanation, but it's clear in my head now what I need to do. And so that will be the episode for Monday, is to actually implement this thing and to hook it up. And I think it's going to go really fast. And then what we're going to do is we're going to tie into the command history so that in the REPL, you'll be able to press up and down and scroll back through all the things that you've typed before. So looks like we got 4 people in the chat room now. So it looks like maybe if I did this an hour later, it would be more convenient for everybody. But I'm sorry, this is the time I have to work with, which is why it's ridiculously early. Sorry. But you can always catch the recordings of these things on YouTube. I do go back and try to put in some chapter headings to say what it is I talked about in each section, so you can navigate to a particular spot. You can also watch it twice speed, so you don't have to listen to me pause like this in the middle of every sentence. And for those of you watching on YouTube, if you happen to be up at the ridiculously early hour of 8:00 a.m. Eastern Time, you can watch this on Twitch. So thanks everybody who showed up for this first week of the ridiculously early J morning show. I'm having a lot of fun. I hope you are too, and hope some of you are getting some value out of this. And I'll be back Monday. So talk to you then.